Hi friend, welcome to the live studies channels. So I am going to discuss about the microservices second part interview question and answer. My first question is, what are the advantage and disadvantage of microservices? The advantage, the improved accessibility, fault isolation, localization complexity, increased elegance, simplified debug and maintenance, better correspondence of the developer with business user, smaller development teams, better scope of the technology upgradation, and there is mainly the disadvantage of the the complicated as the whole, require accuracy pre-planning, module dependency are hard to calculate, less control over third-party application module in interdependence are challenges to track, more opportunity for molecular interactions, complete into testing is a difficult, deploy challenges. Move to the another question. Another question is, what what are some kind of challenges that distributed system introduce? When you are implementing microservices architecture, there are some challenges that you need to deal with every single microservices. Moreover, when you think about the interaction with each other, it can create a lot of challenges as if you pre-plan to overcome some of them as standardize them across all microservices, then it's happen that is also become easy for developers to maintain service. Some of the most challenging things are testing, debugging, security, version measurement, communication, synchronization or asynchronization, state maintenance, etc. Some of the cross-cutting concern which should be standardized are monitoring, login, performance improvement, or deployment security. Move to the another question. Another question is, on what basis should microservices be defined? It is very subjective question, but with the best of my knowledge, I can say that it should be based on the following criteria like business functionalities that change together in bounded contexts. Service should be testable independently. Changes can be done without affecting client as well. Dependent service. It should be small enough that can be maintained by 2 or 3 developer. Reusability of a services. Another question is how to tag service failure when there are dependent service. In real time, it's happened that a particular service is caching a downtime, but if the other service are functioning as per mandate. So under such conditions, the particular service and its dependent service get affected due to the downtime. In order to solve this issue, there is a concept in the microservices architecture pattern called the circuit breaker. Any service calling remote service can call a proxy layer which act as an electronic circuit breaker if the remote service is slow or down for an attempt. Then proxy layer should fail fast and keep checking the remote service for its availability again. As well as the calling service should handle the error and provide retry logics. Once the remote service resume, then the service start working again and circuit become complete. Is this way all other functionality work and expected only one or the dependent service get affected. Next question is, what should one do that troubleshooting become easier in a microservices based architecture? Yeah, it's a good question for this. This is a very interesting question in monolith where HTTP request waits for response, then the processing happen in memory, and it makes sure that the transaction from all such modules work at its best and ensure that everything is done according to expectation, but it is become challenging in the case of microservices because of all services are running independently. Their data store can be dependent. REST APIs can be deployed on different endpoints. Each service is doing a bit without knowing the context of another microservices. In case, we can use the following measure to make sure we are able to track the error easily. The first point is services should log an aggregator's push log to centralized login server. For example, like LX track to analyze. Second point is unique value as per client request, like correlative ID, which should be logged in all the microservices so that error can be tracked on a centralized login server. Third point is one should have good monitoring in place for each and every microservices in an ecosystem, which can record application metrics and health check of service traffic pattern and service failure. Another question is how should microservices communicate with each other? It is an important design decision. The communication between services might or might not be necessary. It can happen synchronizationally or asynchronously. It can be happen sequentially or it can be happen in a parallel. So once we have decided what should be our communication mechanism, we can decide the technology which should the best. Here are some of the example which you can consider. Communication can be done by using the some query services like rabbiting, Actimems, Kafka. This is called synchronization communication. Direct API call can also be made the microservices. With this approach, inter-service dependency increase. This is called the synchronization communication. Like a web hook to push data to the connect client and services. Another question is how would you implement authentication in a microservices architecture? Is a very most important question for the interviewer room. There are mainly two ways to achieve authentication in a microservices architectures. First point is a centralization, means all the microservices can use the centralization store and user authentication can be achieved. This approach work but have many drawback as well. Also the centralization store should be protected and services should be connected securely. The application need to manage the state of the user, so it is called stateful session. Second point is the token based authentication authorization. In this approach, unlike the traditional way, information in the form of token is held by the client and the token is passed along with each request. A server can check the token and verify the validity of the token like expiry, etc. Once the token is validated, the identity of the user can be obtained from the token. However, some encryption is required for security reason. JWT JSON Web Token is the new open standard for this, which is mainly used in a stateless application. Or you can use auth based authentication mechanism as well. Another question is what would be your login strategy in a microservices architecture? Login is a very most important aspect of any application. If you have done proper login in an application, it is become easy to support other aspect of the application as well, like is order to be debug the issue. In order to understand what business logic might have been executed, it become very critical to log important detail. Ideally, you should follow the following practice for login. In a microservice architecture, each request should have a unique value like correlation ID, and its value should be passed to each and every microservices so the correlated ID can be logged across the services. Thus, the request can be tracked. Login generated by all the services should be aggregated in a single location so that while searching become easier. Generally, people use ELA track for all the same so that it's become easy for support person to be debug the issue. Okay. Another question is, how does Docker help in a microservices service architecture? Docker help in a many way for microservices architecture. First point is, in a microservices architecture there can be many default services written in a different language, so a developer might have to set up few services along with its dependency and platform requirement. This become difficult with the growing number of services in an ecosystem. However, this become is very easy if their service run inside a Docker container. Second point is, running service inside a container also give a similar step across all the environment, either development, staging and production. Third point is, Docker also help in scaling along with the container orchestration. Fourth point is, Docker help to upgrade the underlying language very easy. We can save many man hours. Fifth point is, Docker help to onboarded the engineer fast. Docker also help to reduce the dependency on IT team to set up and manage the different kind of environment requirement. Another question is, what is a distributed transaction? It's a very most important question for. It is distribution transaction has two or more network hosted that are engaged. Transactions are handled by a transaction manager that take care of developing and handling transaction. If the transaction involve more than one peer, transaction manager of each other peer communicate with each other using subordinate or supervisor relationship. Same way, resources are handled by the resource manager that also coordinate with the distributed transaction coordinator for transaction atomicity and isolation. Another question is, what are coupling and cohesion? Cohesion. The strength of dependency between service in a microservice architecture is said to be a coupling. Cohesion refer to the related logic between two or more services. The entire concept of microservices is based on the ability to deploy and update service while keeping another service intact. Hence, the loose coupling and high cohesion is the key to a microservices design. Another question is, what is the circuit breaker pattern? Is a very most important question. Circuit breaker pattern. Microservices often need to make a remote network call to another microservices running in a different process. Network call can fail due to many reasons, including brittle nature of the network itself, remote process is hanging, or too much traffic on the target microservices than it can handle. This can lead to cascading failure in the calling service due to thread being blocked in the hang remote calls. A circuit breaker is a piece of software that is used to solve this problem. Okay, like a hanging problem. The basic idea is a very simple, rough. A potentially failure remote call is a circuit breaker object that will monitor the failure timeout. Once the failure reach a certain threshold, the circuit breaker trip and all further call to the circuit breaker return with a error without the protection call being made a call. This mechanism can protect the cascading effect of a single component failure in this system and provide the option to gracefully downgrade the functionality. A typical use of circuit breaker in a microservices architecture look like the following diagram. It's not very important question diagram. The typical circuit breaker implementation, hence a RESTful is a REST client called the recommendation service with the further communication with the book service using a circuit breaker call wrapper. As soon as book service API call start to fail, circuit breaker will be trip the circuit and will not be make any further call to book service until the circuit is closed. Another question is, what are open, close and half open state of circuit breaker? Circuit breaker wrap the original remote call inside it, and if any of these calls fails, the failure is counted. Then the service dependency is healthy and no issue are detected. The circuit breaker is in closed state. All invocation are passed through the remote service. If the failure count exceed a specific threshold within a specific time period, the circuit trip into the open state. In the open state, call always fail immediately without even invoking the actual remote call. The following factors are considered for tripping the circuit to open state. An exception threshold HTTP 500 error can not connect. Call take longer than the configured timeout default 1 second. The internal thread pool like a semaphore depending on configuration used by hashtricks for command execution reject the exception execution due to excited resource pool after a predetermined period of time, by default 5 seconds. The circuit transaction into a half open state. In this state, call again attempt to the remote dependency. Therefore, thereafter the successful call transition the circuit breaker back into the closed state, while the failure call return the circuit breaker into in a open state. Another question is, what are use case for circuit breaker pattern and benefits of using circuit breaker pattern? The first point is synchronization communication over the network that is likely to fail is a potential candidate for circuit breaker. A circuit breaker is a valuable place for monitoring any changes in the break state should be logged so that the enable deep monitoring of microservices. It can easily troubleshoot the remote cases of failure. All places where a degraded functionality can be acceptable to the caller if the actual server is struggling down. So is another question are arise is what is the benefits? The benefits is the circuit breaker can prevent a single services from failure the entire system by tripping off the circuit to the faulty microservice. The circuit breaker can help to offload requests from a struggling server by tripping the circuit, thereby giving it a time to recover. In a providing a call providing a fallback mechanism where a stellar data can be provided if real service is down. is very most important question. Question is, what is Hastrix? Hastrix is a Netflix implementation for circuit breaker pattern that also employ bulkhead design pattern by operating each circuit breaker within a on thread pool. It also collect many useful metrics about the circuit breaker internal state, including like first point is traffic volume, request volume, error percentage, host reporting, literacy percentiles, succeed, failure, and rejection. There are some points. But another thing is all these metrics can be aggregated using another Netflix OS protection called Turbine. Hastrix dashboard can be used to virtualize these aggregated metrics, providing excellent visibility into the overall health of the distributed system. Hastrix can be used to specify the fallback method for execution in case the actual method call failed. This can be useful for graceful degradation of functionality in case of failure in a remote invocation. The first point is like enable circuit breaker in a main application using Hastrix command fallback method. Okay. Another question is what are the main feature of the Hastrix library? Hastrix library make our distribution system resilience adaptable, quick to recover to fall. It's provide three main features. Like first point is latency and fault tolerance, real time operation and concurrency. It's help stop cascading failure, provide decent fallback and graceful degradation of service functionality to come to confirm failure. It work on idea of fail fast and repeat recovery. Two different options, namely threat isolation and the semaphore isolation, are available for use to confine failure. Real-time operation using the real-time matrix, you can remain alert, make decision, effort change, and see result. Concurrency means the parallel execution, concurrency, aware request catching, and finally automatic batching through request collapse improve the concurrency performance of your application. For example, GitHub. Another question is how does Hastrix implementation bulkhead design pattern? It's the most useful question. What is a bulkhead design pattern? The bulkhead implementation in a Hastrix limits the number of concurrent call to a component service. This way, the number of resources, typically threads, that are waiting for a replying from the component service is limited. Let's assume we have a facilitate web e-commerce application component using the remote network like RESTful and HTTP request. Another is a product catalog service, product review service, order services. Now let's say due to some problem in a product review service, all requests to this service start to hang our timeout, eventually casing all requests handle threads in webfront web application to hang our waiting for an answer from reviewing services. This would make the entire webfront application non-responsive The result behavior of your wavefront application would be same if request volume is high and review service is taking time to respond to each request. So the the high-trick implementation for the Bulkhead pattern would limit the number of concurrent call to component and would be have saved the application in this case gracefully decreasing the following setup: get gateway cache. Central API gateway can cache the query result as per business need and provide improved performance. This way we can achieve caching for multiple services at one place. Distributed cache software like Redis or Mac memory cache can be used in this case. Third level is client side caching. We can set cache header in HTTP response and allow client to cache the result for a predefined time. This will drastically reduce the load on server since the client will not make repeated calls to the same resource. Servers can inform the client when information is changed, thereby any changes in the query result can also be handled. E tag can be used for client side load balancing. If the end client is a microservice itself, then Spring Cache support can be used to cache the result locally. Another question is how auth to work. Do you know what auth 2 like a authentication label security? Auth 2.0 is a delegation protocol where the client mobile app or web application does not need to know about the credential of resource owner in the user. Auth 2 define four roles like a resource owner, resource server, authorization server, and client. The resource owner is the person or application that own the data to be shared. When a resource owner is a person, it is called an end user. Resource server, the application that hold the protected resource. It is usually a microservices. Authorization server, the application that verify the identity of all the resource owner, user, client. Their server issue access token after obtaining the authorization. Client, the application that make a request to resource server on behalf of resource owner. It could be a mobile app or a web application like Stack Overflow. Thank you for valuable response and thank you for listening. Please like, share and subscribe this channel. Thank you.